Good morning, good afternoon, good evening, gentlemen and ladies. Today we have Simon Dewulf with us, and he's a very well-known figure. And he has come up with a very interesting topic, and that is advancing innovation through property and function neural networks in patent analysis. So all of these keywords, when we look at it, so everything is very like innovative and very new, and the combination of these new innovative terminologies. So I know everybody would be very keen to listen what is coming up. Simon, I would request you to take over the session and briefly introduce yourself and go with your presentation. Thanks for being with us.
Thank you, Sandeep, and hello from Australia. Thank you for having us today. As we discussed beforehand, I would like to present a little bit how we have moved from approach to Profan. Some examples given in what the capabilities are, and then a short part on what to do also with GPT and some Gen AI. And then finally, we are open for discussion or even for some presentation of the tool itself. So let's start. So from TRIZ to Profan. Profan is basically the function, Profan property, fun from function. They could also just be fun. And just to start up with some examples of property function movement. So you have a property, for example, here from a double window in a glass, and kind of go to a new solution, which we all know now is this double insulating glass. So the function is kind of transferred by transferring the property. Here we have the same. We have a curvature or a spiral that can help to be big and small, and then you can therefore have it in a hose. Same with a toaster, and these are classical examples. If you go for a projector as a projected adjective or property, you can get a projected keyboard, for example. You could say, I'm working with food, and it's on one side toy. So if you say toy food or food toy, same way you can basically merge them. A property here of zip, you could say zippability, or how even, and you put that into headphones and you get zippable headphones. So always the same idea. You have some kind of benefit in a product that you can transfer into another product and therefore create its capability in there. Some very warm-up examples here also, being able to charge chargeable battery by taking a USB charge form, or even a surface, which has now been done in the Bugatti car, where actually they are using the golf ball surface to have less friction, 70% less friction. Took a bit of time. So in future, I think with AI, it will be very exciting to be able to make these combinations, even with graphical images here, as you see here, where you have a golf ball and a car and a fish, and you bring it all together and you get this weird design. But it looks a bit like what we've done in the past with biometry, and how can you, for example, learn from nature and copy some properties and functions from that. Very good. So let's start with the beginning. Profan basically is a innovation logic. It's a step-by-step process to think in terms of properties and functions only. And a property is basically a special feature, a characteristic. Anything that it is related to the science of things. It's related to what it basically has as attributes of properties. And the function, of course, as we know, is what it has to do. And the interesting part is there is always a connection between a property and a function. If the property has no function, then it shouldn't be there. But if the property has a function, basically that's the link between what it is and what it has. So for example, here, latest technology here from this year is a transparent TV to see through. So it's a property and a function. Now the system of Profan is very simple. We just use 3 steps. The first step is really about what we want from a product or a process. And in there, we use the value equation. We want more good, less bad, easier and cheaper. We say more performance, less harm, a better interface and less cost. And finally, also, we use the resources, still the 9 windows from TRIZ, which are a very good way of structuring resources. So we make a wish list and you say you need something like rapid cooling or cutting or emulsifying. And then in the second step, you basically look at the properties and the functions and you ask who else actually talks with these properties functions. Very classical TRIZ thinking, but through properties and functions. And you make this kind of open innovation map in which you connect your field with other fields. And then finally, in the third step, you can also create by saying, if I look at my product, if I will have to change it and make an innovation, I'll have to change something. What can I change? Well, I can change properties. Show me what properties I have. I will challenge them, change them, and then create more or better or new function. And that network, actually, I would like to go through with you today. Now, a little case study as an example. So you can start with saying, here is a case study where a Dutch company is making cream and said, we're trying to prevent oil separation. You take that function and you find in, for example, the food industry, how do they do that already? You find, for example, solutions in peanut butter, and you say, how can I now stabilize my cream by using stabilizers? So again, you made the connection either through the property or the function and find and then transfer that knowledge. But let's build it up from the start. So from the start, we could say profund, properties, function, spectra, and variations. We choose here a list of 11 properties that can be changed in your system. Now, if we think about 11 properties and you have then every property basically is in a spectra of variations of that property. And the beautiful part about being in that variation expressed in language is that, as we know today, everything goes to language models. Now, this is a language model where you can say, if you want to change a process, you'd have to choose one of these example adjectives. And that's a very key part of our research, is to be able to ask patterns or any data for adjectives, because adjectives actually express the property. So once we see here that we have, for example, 11 spectra, and corresponding we have now put in this list 7 variations, of course more of them, but even with 7 variations, you're getting to 7 to the 11th or 2 billion possibilities of different variations only about these spectra. So that's a whole lot of potential product variations you can make just based on these spectra. Now you can go to the patterns and say, show me what type of variations are there in, say, paper. And then you can get something like this, where you see on the top, we talk about porous and hollow and segmented. I'm just taking a few, I just chose 20 of them. And then in this 20, you can see which actually have a set of these variations here in their paper. For example, one that is corrugated and cylindrical and flexible and elastic. And you say here, this one talks about it is corrugated, it's flexible, it's cylindrical, and it's elastic. So you can already find, it's almost like a DNA of a product. What are all the words that actually are connected to expressing the variation of this product? And therefore you can actually mine them and then see where you can change it. Now that's why I put a little button here on the front, on the left side, saying it's a bit like a something you can turn from left to right. And from every of them, you create basically a different system. Now I looked at, sorry, the second one shouldn't be there, just on the pictures, I looked at what were year's most selling products in India and what are the markets and what are the properties and functions. And they're very simple. If you look at, for example, properties of yoga mats here or powders or flexibility, I didn't know that just the simple product to hold your phone in the car, which uses resources like the window here or the rear mirror, or even the blower here of the air. That's a 1 billion market. It's crazy. But you can see it's about flexible to hold or direct. It's about flexible to hold or groove to hold. Or here, even the 1 billion marker is a simple thing with JSL, which is just an elastic to stretch. So what you can see is that a property basically is connected to a function. If it's elastic, it can stretch, bend, absorb, retain shape, and so on. That's one thing that can do. But in the opposite way, you can also say, because here you're just exploring when you change a property, what kind of functions you can get. But you could do it the opposite way and say, if you know your function, then you can see which properties can achieve my function, because I can insulate with porosity, but I can also insulate with the reflective surface, for example. Or I can filter with a powder, and I can filter with a sponge, and they're different things. So you can basically see with language what kind of adjectives actually achieve my verb. Because at the end of the day, here, functions are verbs, properties, adjectives. So you can find what are the connections between the adjectives proposed in the text, in the patterns, in the variations that achieve my specific verbs that I'm looking for. So I looked a little bit at where TRIZ connects to this method. And of course, TRIZ is a fantastic method. And I wouldn't, I think you just need a lot of experience, of course, to use it. But if you see at these kind of variation spectra, actually there is a big correlation between principles and properties. Because a principle like, for example, principle 24, 25 here, or flexibility, flexible shells 25, or porosity being porous materials 31, you see all these numbers here, they are actually correlated and part of a certain property spectra. So they're just asking you, why don't you change and segment something? Or why don't you make it flexible? So that's why often in some of the softwares that they're building for TRIZ analysis, and they're trying to find the conflict, and some universities are working on that, and often they always come back with principle 34. Principle 35. Why? 25 is just saying change a parameter. You could say change a property. And at the end of the day, that's what all the things are mostly doing. They're changing a property. Question is which property? So 35 is a very present principle, but also a very vague one, because it's just like, you want to solve the problem, change something. Whereas the others are quite close to what you should change. For example, change the shape, or change the surface, or change transparency. And in the same way with linking to principles, you can also link to trends, because of course, as you know, there is links between principles and trends. In the steps of the trends, you can actually see you have to change, for example, make it, say, flexible. Dynamization is about making it flexible. But dynamization is also about changing the state, because you start with going from immobile to jointed to flexible, and then you go to liquid gas field. So that's changing state. So it is a mixture of two properties that actually then brings the whole trend. Sometimes it's clean, like if you say space segmentation is actually only about porosity. It's from full to hollow to multiple hollow to capillary. It's all about hollows. And maybe at the end you add some activity. Whereas if you see object segmentation, again, is a combination, because object segmentation, it's about, in the main way, it's about going from solid to liquid to gas to fields, which is our state change. But in the steps between them, they segment, which is segmentation, where here they then make the solid in small parts, make the liquid in small parts, going to sprays or foams. So actually, if we clean it in a way where we go back to actually these trends are there, but we can reduce them to properties. One of the big advantages you have is that you don't have to teach anybody any new things, because every engineer will know their properties. Every inventor will know what a system is, and then we can look at where we can change things. And of course, to look into patterns with AI, it's more difficult to start learning a whole system about what is dynamization, where you could just ask, where did they change flexibility and where did they change state? Now, there's not all principles fit in there. There are some principles which are more about this first step, which is about value and resources. If you think about taking things out or changing things in your 9 windows before or after, turning things around, or even the philosophical principle 22 of blessing in disguise or discard and recover. There are more things that you do when you want to reach ideality by looking either in the 9 windows or in the value equation. So this is a bit the links between, on one side, the TRIZ approach, and then actually the simplification of bringing it all down to properties and functions. Now, sorry, that's not the best slide, but it basically shows you that on one side here on the left, you can then make a matrix of what are the properties that you could change if these are the functions that you would gain. So if you say, for example, I want grip, well, grip with porosity, that's like a, let's say, a bowling ball. But I can also have grip with a surface, which could be on my toothbrush. Or I could have grip with a shape, which could be a ski pole. Or I can have grip with flexibility, which could be something which is like a flexible holder and therefore it takes your shape. So it basically shows if you have a function that you require, show me what property I should change. Or oppositely, if you have a property that you can change, what are the functions? If you really want to explore, what can you do with porosity and see if you want to filter or hang it on something, if you make a hole or something like that. These are very specific, and these are like the 11 we had. But then if you go into other domains, and that is the advantage of working with properties and functions, you don't have to stay in a mechanical field. You can ask a system and say, what about properties like reactivity or solubility or conductivity? These are all different properties that are related to chemistry. And again, there you can see these are helping you to cut. That you gain. Same maybe formula.
Oi,
What are the
oi,
functions that achieve my goals?
वॉच बाहेर
Sorry?
वॉच बाजारान उठ पालक सांगला मगो फोन
Tell me a
केला
question.
मगो बेबी करचे पडटले घर साफ कर कितें कर मगो कशें करतले बरे काल मेसेज घाले
Maybe
सगळ्यांक फुडलो वर्सा करता
Hello,
म्हणून कितें तरी
I can ask you
कर
to.
हा
Yeah. Hello. Please mute yourself. Sorry, Simon. Simon,
No
you may
problem.
continue. Yeah.
I wish I could understand it, but it's a language I can't. Even though I was 4 years in India, I don't speak it. But yeah, so that's a bit the idea. So you actually go to a customer and say, you're making, I don't know, plastic windows. Let's see what are your main properties and what are your main functions, and therefore make your own kind of matrix. So that's this part. Now, so quite interesting if you now, instead of thinking about conflicts where you want something and something you don't want, you could also think about how can I make certain properties coexist in my system. For example, I want a strong and a light packaging. Now, immediately, the first thing you get from Profile, oh, well, you know, strong and light has been shown in other domains to be change these properties. Yeah, it could be a Formula One car or an airplane, and say they've all integration matrix and the principles. But here you basically get what properties have you seen in other products that have made something strong and light. And then you can go to the associated adjectives and say, if integration is about composite, integrated, reinforced, and so on, this is actually an output from the patents. So I've just asked all the patents on paper packaging, and I've asked, show me the examples of where they're making a strong paper and light, and show me how. And one came out with inflatable packaging. Now, it would have been very rare that I would have looked at can I find something like inflatable packaging? You'd have to make the link with tents and maybe with kite surfing and so on, and to see inflatable. But there I could just click and say, huh, some people have actually made inflatable paper tubes, very small, that are connected between two papers and that give you a very strong or strengthened structure without adding much weight. So it kind of gives you that rosetta between, on one side, an innovation method, and on the other side, a whole bunch of patent data in the area of, in this case, paper packaging. The other one is that if you actually go back to the function database, just to go through a few of the tools here of TRIZ, if you look at the classical question here of how do we move water out of a glass without touching the glass, as you know it, then we go, and normally I think there's about 48 ways to move a liquid in the function database. Every of these technologies is actually connected to a property they're changing. I mean, if it's about absorption, you're using porosity. If it's about Coanda effects, you're using a certain surface, and so on. So what can be interesting is that now we can also connect basically all the technologies to properties, because there's a property that enables that technology, and that links to, because it has, for example, cavities for the function absorption. So there's a whole work that has to be done there. We can actually link, of course, sometimes some technologies use more than one property change, but at least we can connect them from one side to the other and say, for example, if you add a field here, it could be magnetic, thermal, electric, gravity, and so on as examples. So again, there you can have that simplicity of classification through properties and functions. Now, just to go a little bit through our neural network approach. So you take here porosity, it can connect to appear, assemble, clean, contain, cool, and so on. So these are some functions it can achieve. And then, of course, you can use that into sports and say, for example, I'm making a porosity, an extra porosity in my shoes for sport shoes, and therefore it can cool better, or it can drain better, or whatever it is the function. And of course, if you look at in general, there's a whole list there, but there's even more than that. They all connect to functions, and these all connect to areas. So we can say properties are basically the science of things. It's what you make if you make something, for example, flexible, porous, and then that scientific effect of being flexible can be used to fold something or contain something, which is then the technologies we call them, the cooling technology or the gliding or the assembly technologies. And in these technologies, then we can say, hey, where will we apply it? Oh, we'll apply it into medical area or in the mining. And so you have these properties, functions, 3 nodes. So you have a neural network. And then, of course, you have your node from your product in and your product out, where you can then actually see 5 lines of 5 nodes where you think about properties and functions. So if I go here to what are all the property function examples, every product that you see, just like we did in the beginning, will have a certain change they made, like they made a hollow staircase here, and they can then contain stuff. But you could just as well say, I made this stairs transparent, and then I can maybe see where my shoes are before I open all of them, for example, because it's probably a hallway opening here. So property, function, and then product. Adjective, verb, and then product. Now, what can be starting to be interesting now when you do a deep learning approach? We're looking at how actually oil could stay in the right place. And this was in the case of a Russian compressor. And then basically you say the problem with the oil is we have to think of what type of oil adjectives are there or properties are there. Is there foam oil, spray oil? Is there solid oil, liquid oil? Whatever that could say, could it solve our problem? And going through that, how do we make because you remember in the beginning we said, you know, if you have some properties and then some functions, or even just the variation of the properties, you arrive to, I believe, 7 to the 11th, which was about 2 billion possibilities. But so you have to be able to narrow your possibilities with your function, because here you want to basically hold the oil in place. And so once it goes through one of these adjectives, it connects to say, hey, property magnetic in my function model, is magnetic connected to hold? It says, oh, actually, yes. And is the property magnetic connected to my function hold in the refrigerant compressors patterns? No, not yet. Wow. And is it connected in the food database? Yes, it is. It has many magnetic oils that hold something. So we have a 0101. We have basically a new idea for oil in refrigerating compressors, because we found an adjective which is not yet patented in the area of refrigerant compressors for holding oil, but it's already been patented in other domains for holding things. So it could actually be applied. So you can actually find new ideas, but you can also build your model all the time, because if you build you find successful connections between properties and functions, you can actually always do a model upgrade when it's not yet in your model, but it's already in other patterns. So, and it's a very simple system, but it could be very useful to actually find and identify what kind of new variations you should make for solving your problem. So Profund versus TRIZ, I would say it's simplicity without functional loss, and that's exactly what we want. It's loss because you can go to all these other properties which are not actually described in some of the principles and trends. Could be temperature or pressure or things like that. So therefore, for us in the tool set, it's easier to actually learn the method. And it's easy to go to other industries which are more into the chemistry or pharmaceutics and so on. But for us, it brings us a fantastic Rosetta, as I was saying, towards looking for properties and functions into patterns by looking for adjectives and verbs. That was one of the main things. I mean, functions and verbs have been a long time around as looking in text analysis. Adjectives and properties is not very much used, and especially not the fact that some adjectives are connected to some verbs. And that flexible is connected to hold. Mostly people looking at subject, action, object, they're looking at the object. They say something is holding that, but it's not the something that holds it. It's the property that makes it hold. It's not what could we say, magnetic something that holds the metal. It's the something is not important. It's the property that actually gives you the ability to do the function, not the actual topic. And that's also why it becomes very applicable across domains, because anything that is flexible can hold or fold. Anything which is, for example, hollow can contain. And for us, the most important part here, especially in days what we are now, when so many tools are coming out continuously, and we're testing a lot of AI on this, is that it has a great potential to actually change into a language model. And TRIZ could almost be based on a neural network between properties and functions. Now, a few examples here from recent work. This is an example of making a 9 windows. You can very easily make a 9 windows with ChatGPT just by asking what is the process of, in this case, making paper. They will give you the process in steps like this. So you make the middle one. And once you have the middle one, you can ask, give me the components in every process, and they'll give you the black stuff here of these are the components. And then you can also ask, give me the surrounding, what's the machinery and so on around it, and it will bring you all this. So you actually can very much prompt for a 9 windows, and then you can go to patterns and say, now highlight all these parts of 9 windows in my patterns. Or even if you say something like, you're working here with fibers, show me in the patents what are all the type of fibers they're using. So it's a very nice interaction between, on one side, which is very good for GPT, and secondly, then the additional detail you can find in patents. And above all, also, it shows you that GPT, you know, it's 80% correct. But with the tool like patents, you can then see which 80% is actually correct and which isn't, because it kind of gives you a way to confirm or verify what comes out of language models. And then you can make it interactive, in which you can say, okay, now show me this mechanical grinder here, and it gives you a whole word cloud of saying this is this grinder, and then you say these are actual patents, and this is the whole patent. So you can build that kind of, sorry, it's a bit automated here, you can build that kind of way of looking step by step from your 9 windows built with GPT towards a step-by-step process going to the actual patent. Now, the other thing here is, again, as I said, properties of processes can also be looked at. For example, adjective process, if you ask, what are all the possible ways of drying in paper? And they say, well, we are mostly drying with air, but look at it, some of them are drying with microwave or infrared. So you get, just by asking a prompt of, I mean, it's not a prompt, it's just a text analysis of patterns saying adjective process or adjective drying, you will find all these ways how to dry or steer, which is basically a very quick access to your processes. And because of this hype of AI, because these tools have been present in the software, but because of the hype of AI, people revert more to this kind of text mining approaches, because they also are very accurate. It's not like it's a text generated. It basically just hits what is in there in your data. And you can also look for functions or effects and see which ones are present. Now, in this area, we have a trend now of showing what is not in your data. And I think that means if you say, for example, in my industry, if we're trying to move liquids, I'm just saying something, these are the ways people are, and that's interesting, but more interesting could be which technologies are we not using? Because if we have a full database, we could say, well, actually, we're not using these areas, these technical elements. And then you could use things like GPT here and say, okay, show me why I would use these new things. Give me the benefits of using quanta effect in my system. So again, an interaction between TRIZknowledge, patents, and then a Gen AI as GPT. In the same way, here I'm going to ask, instead of using adjective, here I'm using noun, in which I can basically look at what is the context of the fiber. And the fiber has cellulose, that's a noun. What are the types of starch we're using? Oh, corn, potato, rice, that's the noun. Which wax are they using in the paper? Paraffin and so on. Very quickly, and of course their word clouds, the bigger, the more they use it. But it's again, with a noun, it's another text analysis, you find the context of, for example, the waxes, the starches, or the fibers. Now again here, let's see what's not there. So you could say, maintenance of packet here, and I'm asking what are all the fibers, and then I'm in terms of generally all the paper, and I'm asking which differences do we have here. And here again, we have, as an example, I always like to look at magnetics. Magnetic fibers are present in some of the papers, but not in packaging. And these are some examples of magnetic fibers. And then again, you go to your new best friend here, ChatGPT, and you ask, okay, why would I make magnetic fibers or use magnetic fibers in packaging? So, oh, well, there's a few things you can do. And then it gives you some, so again, you're exchanging what you find in patents, what you don't find in patents, therefore opportunity, and then how it could relate to your packaging. Now I have one more example here to close by, because I think it's quite an that are in technologies and patents. There's a very easy. We don't want to read patents, as you know. This one is, I think it was 22 pages. So one of the things you can do with our software or many others, I think, is you extract your data from patents into Excel. Why? Give the parts of your patents locations. So you say you have abstract column, you have a description, you have your claims. Therefore, it allows you to design prompts that actually go into different places. Because here I'm asking, well, can you find the main problem in the abstract section or description? The main solution then to that problem you can find in the abstract or the claims. And the advantage over prior art, have a look in the description. So once they do that, GPT gives you a long text of saying this is the main problem, solution, advantage, and then basically the rest is cosmetics, because I'd like to have it in a table. Never get the right table, it's kind of a different one. So I say this is good, but please give me a table which is problem, solution, advantage over prior art. Once you have that, take out your patents and put it in there. We'll try and automate that, but for now it's quite nice, because then you basically have an easy way of looking at a patent, finding here the link of it, the abstract, the drawing, or more drawings. What is the problem? What is the solution? And what is the advantage over prior art, which is so much faster than trying to translate the abstract and the claims into normal text. Conclusion. They've asked me, Sandeep, to have a short discussion on this field. So much going on anyway. But one of the talks that was there not long ago was a conference they've organized in, I think it was Belgian guys, and they made autonomous innovation. And one of the big talks from Harvard there was a person inventor versus a person with Gen AI. And there was a lot of people in that talk of what is the difference in how you perform with or without Gen AI. I think for us that are in TRIZ, this is really very far from reality today, because we could say maybe the first patent was somewhere in the 1400s, and this was an inventor, innovator that didn't use that much tools. But then we moved on. And then I think if you think about what the work has been done from, for example, Alex Osborne on brainstorming and the guys from Synectics, I think in the 50s also TRIZ research started. De Bono, you had Scamper, Sipsy. Many of these tools have become more beneficial, I think, already than just having your comparison between your ideas and your ideas with Gen AI. And if you go to the next one after 2000, there's been a lot of innovation methods. There's been a lot of patent work. We had one, patent inspiration, but there's, I think, not so many, but there's a few tools that actually use, or at least there's some people that use patents for inspiration. And this become a lot of text grammar. And sometimes the text grammar is actually really, really cool. Just like we said now with adjectives and verbs, but it can be for many other things. The semantic analysis can be good. And you can almost create artificial idea generators with it by just switching adjectives that actually link to the same verb, for example. So that was till 2012, and then it moved on towards interesting free tech like Word2Vec that came, which can allow us to do a lot of things like finding similarities between words based on their context, in which you could find sometimes why there is a link between, say, mining, exploration, and precision agriculture. They're, as you would say, two very different domains, but they seem to have all the same context and therefore fertile ground for tech transfer. So that has helped us also to develop this profile idea. And if you look at today, it's not only the innovation methods, but within the innovation methods, AI will start to be used, which for us, I think for people in TRIZ is a fantastic new thing. And we should actually head this space of automated ID generation for complex problems. And that's really a hole in the whole process of AI, where AI is mostly used now to generate in the beginning of the process and get some market intelligence, and then maybe customer minor requests and so on. But the real problem solving part, it's there, but it can be improved a lot if we can start to translate our way of thinking of systematic innovation or TRIZ-like methods into AI systems. Even into how to make prompts, even there AI could actually help how to design prompts. And that goes then towards, for example, also patent expiration, where now you could say we can have alerts. But why can't we have an AI that actually already works for us and doesn't give us just the alert of the company that is competing with us, but finds, say, oh, this is a technology that actually could be interesting to you. Why don't you have a look at that patent, which is completely out of your domain, but could actually come into your domain? So in summary, I think going from an inventor to a systematic innovator in the 90s, we kind of moved towards almost a technology journalist over time, where it was not only about what you find, what you can think of, but also what you can find and report. And you see that a lot of large companies bought their best innovations rather than develop them themselves. And then going towards an innovation editor, because then you start to already see that it's almost editing what exists and what can be created. Finally, towards what we could say, I heard that word within one of the companies, master integrator, where we have all these tools now and we need that general kind of knowledge and still some deep knowledge in different domains, but being able to integrate it all and bring it all into one mission of a certain company. So thank you very much. That's the slides from now. I think some of you might have also seen the previous process innovation slides that I gave last. I'll also send you that, but that's a bit in response to that last presentation I made at TRIZasia. Thank you, Sandeep.
Thank you, Simon. Moving towards innovation to integrator, innovator to integrator, it is really a very mesmerizing journey, and you have given very lucid and very practical examples for these things. So thank you very much for that. And participants, the forum is open for questions. Please feel free to ask any question which you have. And we have our expert who has himself developed this, so he'll be in very good position to satisfy your queries. Let me check
So,
the
Sandeep
chat.
sir.
Yes, please go ahead.
Yeah, good afternoon, Harshagangan. May I ask a question?
Yeah, please.
Yeah, Dr. Simon, thank you very much for this enlightening presentation and sensitizing us about the upcoming trends and how we should look at the changing things. Thank you very much for that. Just a small question maybe for the students, because my son is a student studying engineering. And ever since I got to know about trees, I have been giving him some inputs, so that it may guide him. Now, with this last slide which you have shown, as far as the basic engineering knowledge or basic knowledge of science or technology, which will be definitely be at the foundation, and then it need to be, you can say, enriched by using the tools and this thing. So is my understanding correct? Because sometimes the young students will be slightly diverted that we can just use various apps and technology and we need not be studying the basics of science. That's how they are in dilemma. That's why I'm asking this question. Hello?
Yes, Simon.
Dr. Simon?
I think
Hello, Sandeep
something
sir,
is
is
wrong.
my
Yeah,
my voice
we can hear you.
was reaching,
Yeah,
right?
yeah,
Okay, okay.
definitely. Maybe some issue with his microphone. He'll come back soon.
Yeah. Maybe I will wait.
Sure.
Maybe we need to inform him that we cannot hear him.
Yeah.
Shall I put it in the chat box?
Sure, sure. Simon, can you hear us? Something seems to be wrong because
Yeah,
initially also, yeah, there were some trouble, but he could join very soon.
yeah.
To everything, because it teaches you about electronics, plastics, materials, metallurgy, and so on. It's a very wide and still quite deep learning. The other thing in similarity is agricultural engineering or bioengineering, which is then the opposite. It's more about all the chemistry of the living things. And the materials about all what is dead, but all the materials. But those kinds of engineering degrees are actually not in one direction, but are very open and help you to see, I think, more of the different domains than if you would, for example, choose to become a metallurgist. Does that answer your question? Was that related to what you were looking for?
Yes, Dr. Simon. So my basic point was that particularly the new generation, as I am seeing in my son, so I thought of asking this question, that the tendency is towards applying the shortcuts to grab, to take a knowledge. But what usually the way we have learned and we have observed that unless you have the basics in place, unless you have learned those in a hard way, you cannot adapt the new things. It may be just superficial, and that's why technology, techniques, apps, everything is available, including now chat gpt, etc., but it doesn't discount the understanding of the basic things in detail. That's what I wanted to inquire, that it doesn't make the importance less.
Yeah, I couldn't agree more. I think it's really true, and there's no shortcuts to understanding how chemistry works, how statistics work. We have to do the things we need and we don't really want. And I think it's very important to have a basic degree in technical fields and eventually, hopefully, an open technical field before we start applying these kind of things, because you can just know much more if you have the basic understanding of how chemistry or how materials or anything in general works on a very small scale. Yeah, it's a tough one for today
Yes.
because
Yes.
we're in a way where everybody just wants to study making money or something as a degree.
Yes.
If this is possible.
That is true. Thank
Thank
you,
you.
Dr. Simon, for that answer.
Thank you. I
Thank
can
you.
see Jürgen. Jürgen has a question.
Yeah, Kedar has a question, like which companies are leveraging this master integrator approach for autonomous innovation and for which products?
Yeah, I think many companies now are looking at, and I mean, we're working for some of the larger consumer, like fast-moving consumer goods companies, and everybody's of course looking at how to use AI for accelerating the process of getting products to market, even if it's not making better knowledge. Does it speed up the time to market in the way than without AI or such tools? So I'd say these people, like the fast-moving consumer goods, they are really looking at that to replace some of the manual work where possible, and being able to, for example, read patterns much faster just by getting already problem solution and advantage of prior art, rather than to go all the way through the whole patent. So people that have to deal with a lot of information and have to be able to make differences in technology-driven companies. If that answers your question.
Yes, I hope Kedar
Yeah.
is satisfied. So
Yeah, thank you.
yeah. If anyone
I
else,
see his one hand up as well, Sandeep.
I have a further question to that. So these milestones were given up to the year 2023 or 24. What is the future of in this direction? What this is going to get evolved into? One is autonomous innovation. What next?
Yeah, it's a tough one to know. I think the systems we're building now are very surprising, and some of the calculations they do are very surprising. So I think the early promise that the internet made, when we all knew when the internet started, and then said, everything is now everywhere, it didn't really come through. I mean, it was still just a big mess and to find things. I think that promise will be more realistic now. I think a lot of other things is that some ideas or some products will be redesigned from scratch rather than optimized from what they are. There is some very interesting ways now to write algorithms that they take away all the assumptions that we have and just say what could be the ideal way of either packaging or whatever thing that you're trying to achieve. So that's a new step. Yeah. Otherwise, I don't know. I think my biggest question is always: will this give us better products? Maybe yes. Will this make us smarter? Maybe no. That's a bit of the danger, I think. I hope that we'll be able to keep our critical thinking skills, and that's why also we propose a little conference this year where we actually align on one side what can AI do, but on the other side also how can we use that to boost our own creative thinking, which I think is still very important to keep the human loop, and actually use these tools to be able to enhance our intelligence rather than just to rely on artificial intelligence.
Thank
We'll
you.
see. We'll be there. Thank you.
Thank you.
and the time will come very soon. It won't take much time. Okay. Akhilesh is there, and yeah.
There's one more hand up there I can see from Jürgen.
Pardon?
There's a hand up from Jürgen in the audience that wants to ask a question.
Yeah. Okay.
sorry.
Simon, can you hear me?
Yes, I can. Hello, Jürgen.
Simon?
Yes, Jürgen.
Hi, Simon here from Ringsburg, AMS Osram. So thanks for your talk. And the conference you mentioned, is it in Offenburg, the Atria?
No.
Which conference?
We're actually looking at designing a kind of hackathon
Okay.
where there's a few companies that put challenges, and then
Okay.
by September they have to kind of see how AI can solve it, and then also do it on the actual
Okay.
day itself.
That's
So
what
kind
we
of-
already did. Yeah.
Yeah,
That's your project we already discussed, right?
correct. Yeah, kind of Robocop.
Yeah. Okay.
For AI.
Yeah. Okay. So my question was, but I think it's not enough time. you offer to make a brief presentation of your work, but I think it's not enough time now. So how you search for, maybe there was one slide, you wanted a light and strong packaging technology, yeah, and then you looked for adjectives and so on. Maybe how you do it, but I think it's not enough time now. Yeah.
We can do it one time, Jürgen. That's not a problem. The thing with
we
strong
do it
and
after.
light, it's an example now that I've used also because we made the book together with Daryl and Boris, and that was in 2003, Matrix 2003, where we spent actually a lot of time analyzing patterns in Bangalore in India and trying to find which principles are solving the new type of patterns after the ones that were studied for TRIZ, which ended somewhere in the 80s. And it's with that kind of similar approach. We now want to see if we can do that with the language of patterns to see what properties actually can coexist, and therefore can you make a property matrix rather than a parameters and principles.
Yeah.
Okay. It's exciting work.
Okay, let's do it offline. So in our next meeting, Simon. Okay, thank you.
Very good. Thank you, Jürgen. Okay.
Thank you, Jürgen, for your question. And there is a kind of a compliment or a suggestion for the management, compliment to the TRIZ and suggestion to the management from Akhilesh that we could have this shown as a strategy, and it would be helpful in getting more higher management adopt the approach of not only TRIZ, but also move from innovation to integration. So yeah, Akhilesh, definitely it is required. And now we are seeing that many people are adopting TRIZ for their innovation and research kind of activities, apart from the day-to-day developments, whatever are required as an innovation. Prashant has got a question. Prashant, would you like to ask or should I ask it? Okay, I'll ask it. How does master integrator approach help predict the direction of evolution of products, services, or technology, like we do in S-curve analysis?
Sorry, could you repeat that? Sorry, there was a little bit of an interference. Is it in the chat as well?
Yeah, it is there.
How does the master integration approach help to predict the direction of evolution of products? Yeah. So basically, I think the direction of products, as we can see in TRIZ, they say, oh, we have these trends, and they always go from left to right, unless they go from right to left. Because it depends what you want. If you want more reactivity, for example, you might go from solid to liquid, liquid to gas. But if you want to go for conservation or transport, you might transport your gas in a liquid form. So you go back. So the idea of having a certain direction in these properties, I think we should let go and think of any variation will give differences. So we have to explore all variations. Sometimes we will go backwards towards a solid instant coffee instead of a liquid instant coffee because we come from liquid to solid. On the other hand, if we look at the main value equation like you have in TRIZ of benefits over cost and harm, or like the battle for ideality, as everything has to be free, perfect, and now, I think those things will still remain. You will have always a push towards more function with less system, more good stuff, less bad stuff, easier and cheaper. And now how can you actually look at that into where S-curve position with, for example, Profen adjectives, you will see that if you see these stages, just like TRIZ and the S-curve, and even Clayton Christensen was saying, of make it work and then make it work properly and then make it work easy and then make it cheaper, that these texts that are in the patterns, if they're related to basic performances, it means the product is probably in the beginning of the S-curve. If it's all about convenience, it's probably about the third stage. And if it's all inventions that reducing cost, it seems to be at the end of its S-curve. So therefore you can actually correlate, and if you want, I can send you a paper on that, where you can correlate actually language and S-curve position, and then find out what are they talking about. Are they talking about making it work from basic, or are they talking about making the cheapest one because everybody knows how it works? So that relates a little bit to that S-curve idea as well.
Thank you, Simon. And
just as a
to
little, Sandeep, sorry, just as a little one,
Yeah.
I put a little site in there, Profan AI. It's nothing about what we do, but it's mainly a site where we're trying to keep up with all the other AI tools, a bit in response to, how to go to master integrator, not only in the invention part of the company, but in so many other things. And how do I make a presentation, or how do I do some market research, or how do I patent? A lot of tools are there, and we hope to update it every month, because it's crazy how many are actually starting every day. I think about 15 new AI companies a day now.
Right.
Thanks, Anip.
Yeah. And to extend to the question of Jürgen, like or the other speakers as well, particularly Prashant, whosoever have some thing which is who are keen in AI. So we are also hosting, like Matri's official will host ITC, that is International TRIZ Conference in 2024. And I've just given you like a teaser of that, which is posted on LinkedIn, and you can just go through it, and it will be held in Dubai during 14th to 17th October 2024. So definitely we'll keep on posting more about that also, and please stay tuned and try to get into that conference, so that those who are very keen about learning and knowing what are the developments in TRIZ, they would be able to get a very good exposure out there. So any other question, participants?
Very good. Yes, thank you. I see there's another question in the from Dan. I don't know if he's still present in the meeting about
Yeah.
how much time there is in an approach. I think we're trying the learning of how to actually use systems like software and so on. Of course, there's a bit of a learning curve to see which buttons to click and things like that. But that's just a few hours, I would say, once you get through that. The main thing is that I think the difference is that your possibility to start from what is I mean, you can ask any engineer, make a list of the properties of your system. They will give you that list. Go hand by hand with them. See, look, what if we change the first one, or this? Who in the patents has already changed this one or this one? So that becomes quite easy to actually look at it that way, because you don't need to really have that whole background and new vocabulary, because the vocabulary you use in properties and functions is a vocabulary you know. And you probably have already worked on some of your properties before you start using this method. So you can see, oh, I've already changed this with success. What about changing the other things? If that helps you as an explanation, Dan. Thank you.
Thank you, Simon. Thank you, Dan, for your question.
See, how crucial is the tool to mine patents, like your company's product? Well, patents, I mean, on one side, patents is knowledge that if I may answer, Sandeep, on that one?
Yeah, please go ahead.
Yeah, so the patents is you can use Google Patents, you can use Spasnet. I mean, there's many tools out there. The difference we want to make is that a lot of the patent tools that were designed in the past were really about who owns what, and can I see what my competitor is doing? But that was where it ended. And I think that the advantage that we have, all of us here in the meeting with this TRIZ thinking, is that we can start to say, hey, but patents are more than that. They are actually also a source of knowledge of other areas that can help me to make this open innovation map and find out who in the rest of the world knows something. So I think just like what patents have done to create the TRIZ methodology, today patents can do many of these things that were done manually by Genrich Altschuler and his whole team immediately with text analysis. That becomes very, very rich, because now we can just have that thinking way of the TRIZ methodology and say, let's write it in a way that we can find who else has actually solved the conflict between strength and weight, for example. So that tool of patents is very good for it. In future, we might also look at papers. We have done some tests with papers, but that's also a possibility. But of course, patents are very strong and very well written and very easy to mine, because you know where the problem is, the solution, the claims, and so on. So that's quite nice.
Yeah. Thank you, Simon. Very apt answer.
Thank you.
Yeah. Okay. So with this,
one more hand up. I don't know if you want to close. I don't know. Up to you, Sandeep.
No hands up, and no
Okay.
question in the text box also. If someone has a quick question, we can always take it.
But anybody wants to give it a trial? I mean, I didn't really go into a demo on how the software works, but anybody who sends me an email, I'm very happy to send you a trial version, and you can give it a go and see how it works. Huh? We are now very happy to be able to offer you all the data because we've been able to make a deal with Questel and APO, and I think we have the most accurate patent database online now, which has become very important for this kind of research.
Oh, that's so kind of you that you are giving the trial version of that. Definitely people will take benefit of it. And guys, please note down the email ID, or you can also contact us if you miss to do it, and we'll convey your like queries and all questions to Simon, and I'm sure he will answer them. So yeah, Kedar, email ID he has already put s@aulive.com.
Correct. Yeah.
Okay. So with this, we come to the end of chapter 20 of TRIZtalks. And again, we'll be coming back on the 23rd of February, which is again the last Friday of the month February. And we'll be coming with another expert, and who will also, we'll announce the name soon. It is yet to be confirmed. And we'll be also coming with more and more information and insights on TRIZ. And definitely, Simon is in contact, and he is very fast at giving the responses. So you can just keep in touch with him. Thank you, Simon, with being with us and giving such a good insights. And definitely we'll find a way wherein we can see the demo of your software as well, and try to have our hands on it. Thank you so much for all the expert knowledge, whatever you have shared, and all your insights. Thank you.
Thank you.
Have a
Thank
great
you,
day
everyone.
ahead. Yeah.
Thanks, everyone.
Thank
Thank you, Dr. Simon.
Thank you to
Sandeep, sir.
all the participants for being with us, even at the odd time of the day or odd time of the night. So have a great day ahead, and good night.
Thank you. Bye.
Good night.
Thank you, Simon. Bye bye.
Thank you, Jürgen. Bye.